Sound check. Sound check. Sound check. Okay, we're back on. I realise I started with my mic off. Sorry, I'm at work. I was trying to just keep it quiet while the vacuum's going in the background, and I completely forgot to turn it back on after doing my little sound check at the beginning. Thank you, Ninja Pirate. You've saved the day. You are also the one responsible for me doing the D&D worked solutions at the moment, so you can credit yourself the inspiration. I got in touch with them. They've given me permission to use their resources, and so I'm working through doing the work solutions to the D&D videos. Okay, back to today's merit of the day stuff. We've got this complex numbers question. Z is 3 plus 2i, so the conjugate is 3 minus 2i. Now, given that this is a merit question, you'll need to make sure that you don't do all of it entirely on the calculator, because questions that can be answered on the calculator only would only ever get you an achieve mark. So you do need to show some steps through, but we can do a fair bit on the calculator. So the first thing is to write down that we're doing this conjugate squared. So it's 3 minus 2i, and then we're going to square it. And we would add on 1 over z squared, and z squared is going to be 3 plus 2i. And I just want to do a quick check that I've got sound coming through again. So it's 3 minus, yep, there we go. All right, so now if we take the 3 minus 2i on our calculator and square that, that will be 5 minus 12i. And then do 1 over. So 1 divided by 3 plus 2i. There we go. That's not a nice... Oh, I forgot the squared. Whoops, there we go. So I'm just going to go back a step. And we'll do the 3 plus 2i. And square that, so that'll be 1 over 5 plus 12i. And now if we do 5 minus 12i and we add on 1 divided by 5 plus 12i, like so. Ooh, and we have something that does not look very nice. It's in decimals, and our question asks us to put it in the form a plus bi. So I'm going to do this. So using our fraction to decimal conversion button there, we can turn it into something that's going to appear as fractions and be a lot tidier and in the form that we wanted it here. So this will be 850 over 169 minus 2040 over 169i. Not very pretty numbers. Oh, I don't know why we've got that. There we go. But given that it's a merit question that's doing some really basic stuff, they're probably scaring you a little bit with the numbers and how they came out. But that's totally fine. It's a totally valid answer to have that kind of ugly looking fraction. Okay, I'll just check where the merit was given for that one. Let's have a look. So the correct expansion. So it was for this bit just here. That one got you an achieved. And all the way through would get you the merit, obviously. Okay, let's take a look at differentiation. So this is a rates of change question. We've got this container that's being winched up vertically from a point P at a constant rate of 1.5. So I'm going to do a bit of highlighting, a bit of writing stuff down as we go. So that gives me a rate at which h is changing over time as being 1.5. Okay. So the dh by dt is 1.5. This is how much this is moving up. So here's our container being winched up in this box here, and it's going vertically above P at that rate of 1.5. We've got some other information. This obviously will make a right-angled triangle here since the object's going up vertically. Then we have a distance of 20 along the bottom. That's on there. We have an angle of elevation just here. Then we want to know at what rate the angle of elevation is increasing when the object is 20 meters above point P. So I'm going to write down what I'm aiming for. This is how I like to do rates of change questions. So first of all, start by writing down the rate that you have been told. And second, write down the rate you're trying to work out. And then you can fill in the missing pieces to get from one to the other. So the rate I'm trying to work out is how much the angle is changing over time. So that's this bit here. What rate is the angle of elevation increasing? So if I compare that with the dh by dt that I've got, to turn that into d theta by dt, I need to introduce d theta on the top, and I need to cancel out dh by putting it on the bottom. Okay, so I'm just trying to get things in line so I can make sure I can see everything I need to. Just 1 second. There we go. I just want to keep an eye on the stream just in case anyone has questions. Right, now I've got the dh by dt that I need as the first piece of that puzzle just here, but I need something that links theta and h. So a formula linking theta and h, we're going to use trigonometry because we've got that right-angled triangle. So h, we've got the opposite, the adjacent, and the angle. So that's going to be tan. And I like to think of it in the little triangles to remember which way around things go. So the h is opposite, which is going to be tan theta times the adjacent, which is 20. So then if I want to do dh by d theta, then tan theta goes to sec squared theta, and the 20 just stays as being multiplied like that. All right, now back to the thing that I'm trying to work out. So d theta by dt will be dh by dt. So I'm just taking this here, and now we're going on with that. So dh by dt is 1.5. Now d theta by dh, we have dh by d theta over here, so we need to flip it over. Now, just to make things a little bit easier, I'm going to turn this sec squared into 1 over cos squared. So we can see what we're doing with the fraction there. and then popping it into this bit to make dh by d theta into d theta by dh, we'll just flip that fraction over. So we've got cos squared theta over 20. Okay, we're nearly there. So let's just get the next bit. We want to know what it is when the object is 20 meters above point P. So 20 meters above point P means that our h is 20. Okay, so when h is 20, we're going to work out d theta by dt, 1.5 times by cos squared theta over 20. So I'm going to need to work out that theta bit. I'll come back to that. So using the link between theta and h up here, we have 20 equals, 20. So h is 20 is equal to tan theta times 20. So tan theta is 1, and theta, if we do inverse tan of 1, okay, I'm going to actually use special triangles because this calculator that's on my computer does not do nice fractions for me. The one that I have, this one, does. So if you have the chance to upgrade to one of these, those are really good. Okay, so let's just go back to special triangles. 1, 1 and root 2 with an angle of pi by 4. And that is on your formula sheet. If you don't memorize these easily, you can look it up there. So tan is the opposite over adjacent, 1 over 1. So then we have an angle of pi by 4. So theta is pi by 4. And if I just want to check it on the calculator, you can see that's the same as the answer that we just got there for the inverse tan. So I have got the angle I'm looking for. Okay, back to where we were, which is popping it in for this value just here. Okay, we're nearly there. Now, cos squared means we do cos of the angle and then square the answer. So just be careful with this one. So cos, I'm just going to use the answer we had in there. It's going to get squared, then divided by 20, and then times by 1.5. We get 0.0375. And just one last thing to add in the units. We're measuring this angle here. We're in radians. So that's being measured in radians, and it's a rate. So it's how many radians it's changing per second. All right, integration. Oh, I did just want to go back. I'll just check where the achieved mark was in there. A correct expression for dh by d theta. Oh gosh, there we go. So I'm trying to just prop this up for a webcam at the minute. Okay. Where was I up to? So correct expression for dh by d theta was this bit just here. So this here was where the achieved point was in this question. Okay, integration. Last one for today. So I'm first of all going to write this down in powers form. So we have x to the minus 1 because it's on the bottom, and x to the minus a half because square root as a power is a half, and it's also on the bottom. Now, if we multiply together things with powers like that, then the powers get added. So minus 1 plus minus half is minus 3 over 2, or minus 1.5, however you like to think about that. Now we integrate this one. Increase the power by 1, so minus 1.5 plus 1 is going to come up the scale to minus a half. Divide by our new power, so we're doing 18 divided by a half. That's the same as doing 18 times by 2, and it happens to be negative as well. Okay, now we'll substitute in the values of 9 and 4. So we have minus 36. X to the minus half means it's over the square root of x. And then we'll take away minus 36 over the square root of x, this time where x is 4. And we'll do that subtraction. So we'll do a negative 36 divided by the square root of 9, which is 3. Take away a negative 36 divided by the square root of 4, which is 2. And we get the answer of 6. And let me just find where the mark scheme is for that one. For achieved, it was getting a correct integration. So achieved was that bit just there. Nice, easy one. I think that's a really lovely merit question. If you get one like that, then you're very, very lucky. Okay, I will line up another one tomorrow. Not sure of what time because I have some meetings after school that are going to run quite late tomorrow. But my classes are now on study leave, so I might be able to get one done during the day. But yeah, I'll post the questions I intend to do onto my Instagram. You can find me by looking up Mrs. O'Graham's Maths if you want to sort of have a go at them before coming to the live. That'd be good practice, and then you can see how I go through them. Okay, nice quick one. Hopefully you're enjoying these little bits of revision. Do short, sharp bursts of stuff just to keep you engaged and getting ready for that exam. It's not too much longer now, and I think most of you are probably on exam leave if you're watching this at the time I'm recording it anyway. So yeah, good luck. Let's keep going, and I will see you again tomorrow.